Hi, welcome back to Maths with Armin. In this video on trigonometry, the topic is trigonometric expressions and identities, and there's a three-strategy approach that I'd like to explain to you, and it will be illustrated by means of suitable examples. This video consists of 5 parts. First of all, we'll give you a brief overview of essential trigonometric concepts you require for the simplification problems and for proving identities. And then I will explain to you a three-strategy approach, general approach to how you can approach simplification problems and how you can approach the proof of trigonometric identities. Then we're going to have some examples on simplification of trigonometric expressions, and that will be followed by applications on proving some trigonometric identities. And then, as usual with all my videos, there's an exercise worksheet. Let's start with a brief overview of essential trigonometric concepts that you would require for simplification as well as for proving trigonometric identities. First of all, you need to know the definitions of the three trigonometrical ratios: sine, cosine, and tangent. So if we have a right angle triangle, there we have angle theta. This is a right angle triangle. So sine of theta is y over r, cosine of theta is x over r, tangent of theta is y over x, which you also maybe can interpret it as opposite over hypotenuse, or adjacent over hypotenuse, or opposite over adjacent. You also need to know your three special triangles: the 45, the 30, and the 60, these special angles here. And these are the diagrams here. You can also get this from your scientific calculator. And then you need to know in which quadrants the three ratios are positive. All the ratios are positive in the first quadrant. Sine is positive in the second quadrant. Tangent is also positive in the third quadrant. And cosine is positive in the fourth quadrant, right? And here we have different angles here. If theta is in the first, 90 minus theta is in the first as well, and 180 minus theta is going to be in the second, and 180 plus, etc. Right? So, but we're going to show you a technique in which you can get these values quite easily. There are three groups of identities that you need to know. We have the reduction identities, and here we've listed all of them. I'm going to show you a technique. You don't have to memorize all of them. There's a very simple technique where you can use your calculator to get these, simplify these expressions here. Then we also have the following basic identities: sine squared plus cosine squared equal to 1, the Pythagorean identity. And then we have tangent of theta is sine theta over cosine theta. Now, the sine squared plus cosine squared equal to 1, we could also have variations of it. If I transpose the cosine squared, I get 1 minus sine squared is cosine squared. 1 minus cosine squared of theta is equal to sine squared of theta, right? Or the other way around, cosine squared of theta is equal to 1 minus sine squared of theta. And sine squared of theta is 1 minus cos squared of theta, right? Then we have, specifically in grade 12, we've got some compound angle identities. Now, these identities you don't have to memorize. They are on the formula sheet, but you need to know exactly where they are located here. As you can see there is an expansion for sine 2x, and for cosine 2x, we have got three options. We'll explain to you when do you choose this one, or the second one, or the third one. And then we've got sine of the sum of two angles, sine of the difference of two angles, cosine of the sum of two angles, and cosine of the difference of two angles, with the relevant expansions there. And please be careful, if you have sine of a sum, you have a sum there. Sine of a difference, you have a difference there. Cosine of a sum, you have a difference there again. Cosine of a difference, then you have a sum, right? Be careful that you don't write down the incorrect formula there. Quite often you encounter in a question the restriction where it says without using a calculator. Now, what do they actually mean? What do the examiner actually require from you, or what is actually the restriction if it's stated without using a calculator? Now, without using a calculator implies that you have the following options. First of all, step-by-step calculations need to be shown. Otherwise, you can't just write down an answer only. Okay. Now, going with that also, quite often you have to make use of special angles. And those are the special angles, the 0 degrees, 30 degrees, 45, the 60, and the 90 degrees there. And if that is not applicable, then you need to draw a sketch. Okay. And if that is not available, you've got one more option, then you can make use of trigonometric identities there, right? So without using a calculator, these are the options there. Either, first of all, you step by step, that's essential. Sometimes you have to use special angles. If there are no special angles involved, then you draw a sketch. And sometimes if you see the sketch is not going to help you, you've got another option here. You can make use of trigonometric identities. So we're going to show you how you can use your scientific calculator as a tool to assist with verifying calculations. When it says without using a calculator, it doesn't mean you cannot use the calculator at all, but you should have step by step. If there's special angles, you need to show the special angles. Quite often you need to draw a sketch, or you just have to apply your identities. I want to show you how you can actually use your scientific calculator without using this diagram here. How to simplify expressions like, for example, sine of 180 degrees plus x, right? So let's not look at that. For x here, x is a variable, and the easiest variable value that you can use is 1 degrees. So always just make x a 1. That's the simplest number to use. So you enter in your calculator sine bracket 180 plus 1, close the bracket, equal, and that's your output. But just focus on the sign that you get there. So don't look at the decimal value. It tells you that the sign of 180 plus 1 is negative. So I know my answer must be negative. So if I want to reduce sine of 180 plus x, the calculator told me it's negative, and the 180, you can just drop the 180, so it just becomes sine of x, right? So you can always get this correct. Instead of looking here, 180 plus, it's in the third quadrant. Remember, you don't have this in the exam. You have to draw that. And in the third quadrant, sine is negative, where the calculator can just always give it to you correctly. Let's take a second example. So we're going to make x a 1 again. Cos of 1 minus 180. And you see on your screen, negative 0. So it's a negative value. So if I'm going to reduce this cos x minus 180, it becomes negative, right? It's a negative value. And when I have 180, it just becomes cos of x. Give me exactly the same value, cos of x. Let's just verify. X minus 180. X minus 180 is in the third quadrant. And cos sine, you can see, is negative in the third quadrant. Right? I'm just using that there. Now let's look at some more examples here. Simplify tan of negative x. So is enter tan of negative 1. And you see the output on the calculator tells you it's negative. So tan of negative x is just negative tan of x. Just becomes negative tan of x. Now if we take cosine of 90 minus x. So we have cosine of 90 minus 1. Just check it in your calculator. It gives you a positive answer. So cosine of 90 minus x is definitely going to be positive. But because I have 90, I have to take the co-ratio. And the co-ratio of cosine is sine. So cosine of 90 becomes positive, but I change it from cosine to sine, right? Also, let's take another example. If I take sine of 90 minus x, so sine is going to be 90 minus x is going to be positive, that you can get from the calculator. And the 90 changes that sign to a cosine of x. Let's take another one. Cosine of 540 minus 1. That answer is going to be negative. So I know cosine of 540 minus x has to be a negative. and then I can just drop the 540 and becomes cosine. The only time it changes is when you have 90. If there's a 90 involved, a cosine changes to a sine, or the other way around, a sine changes to a cosine. Now here's a practice exercise with 6 examples. Should take you less than 3 minutes. So quickly do that. Use your calculator. Determine whether that is positive or whether it is negative. Right? So let's see. So just try it quickly to do each one of them. Okay, let's look at the first one. Sine 360 minus 1 gives me a negative answer. So the answer is going to be negative sine of x. Tan, you can make that a 1. 1 minus 180. So that will be positive tan of 2x. There's a 90 involved, so that cos of x minus 90 is also a positive answer. So that answer there will be positive sine of x. Here's another 90. 90 plus 1 or 90 plus 2 gives me a positive answer. So the answer is going to be definitely positive, and positive cosine of 2x. Tan of 720 minus 1, you see that answer is going to be a negative answer. Okay, and that gives me a negative tangent of x. 450 plus 2x, so that's 450 plus 1 or 450 plus 2. That gives me a negative answer. But if I take 360 away from 450, it leaves you with that's correct, a 90. So I also need the co-ratio in this one here. Okay, so I just suggest you to practice this. Now I want to share with you a general approach that involves 3 strategies, and it's only these 3. If you follow these 3, it can always assist you when it comes to a simplification of a trigonometric expression or the proving of a trigonometric identity. Just 3 basic rules that you need to follow, and if you follow this in this particular order, it can always assist you to get the correct simplification or to do the proof of an identity. Now let me share with you these 3 strategies there. Okay, first of all, the one I refer to as test strategy number 1. Okay, and this is a strategy that you always, when you have a problem, always see whether you can simplify. So the emphasis, always see whether you can't simplify. Right? Now, if you can't simplify, then there is another option for you to use. And this option you use if you cannot simplify. And this I refer to as strategy 2. And this is then you apply factorization. Right? Now, if simplification does not work and factorization is not helping you, then you have one more option left. Only one more. And that is what I refer to as strategy number 3. And this is then you use a trigonometric identity, right? And you always should try them in this order. First, see whether you can't simplify. If you know you can't simplify, then you ask yourself, can't I factorize? And only if you can't simplify or factorize, then you use identity. Don't just in the first step immediately use identity, right? And you try to do it in this order here. First, see whether you can't simplify. If that doesn't help you, you try to factorize. If that doesn't help you, you use a identity, right? Don't jump to identities if you can factorize, right? Because this, if you follow this procedure, it will always be able to simplify your expressions completely. Now let us look at each one of these 3 strategies in a little bit more detail. Let's start with strategy number 1. As you recall, we said that you'll always try to simplify. Now what do we mean by simplifying? That means you add and subtract like terms. So if you see any like terms, you can add or subtract them. Okay? Then if there are fractions involved, then you'll find a common denominator. Okay? If there are any brackets there, you'll expand or you remove the brackets. Or if there are factors that you can cancel out, then you cancel them out. And if there are any reduction formulas that you can apply, apply them. So this is what you always try to do first, right? You ask, can you simplify? You ask yourself, is there any like terms? No. Are there fractions? No. Are brackets? No. Are there, yes, I can maybe cancel out. Or if you see a reduction formula, try to eliminate the reduction formula immediately there, right? So this is what you should give first preference to doing these operations first, right? Adding or subtracting like terms, adding or subtracting by using a common denominator if there are fractions. If there are brackets to be removed, you expand them, and then, you know, after expanding them, maybe you can get like terms again. And if there are things to be cancelled out, cancel out. And if there are reduction formulas, so you always give first preference to these operations here. Now let's just look at strategy 2. Now, if it's not possible to apply strategy 1, in other words, there are no like terms, or there's no fractions involved, there are no brackets to be removed, there's no cancelling that can be done, or there's no reduction identities, then we apply our next strategy, and that strategy is we apply the techniques of factorization. Now, the factorization techniques generally are the common factor, the difference of squares, the trinomial, or sometimes we might come across some grouping techniques there as well. Okay, so to illustrate this, let's look at an algebraic example. Here we're required to simplify this expression. So we look at the numerator. There's nothing I can add there, right? There's no like terms. If I look at the denominator, no like terms. I can't even cancel here, right? So I can't add or can't subtract or I can't cancel. So the only other option for me now is that I want to use factorization, right? And if I look at the numerator, what type of factorization will we get for the numerator? That's correct, a common factor. And for the denominator, so we factorize both the numerator and the denominator there. Okay, now we want to simplify, right? Now you're back with simplification again. To simplify, I notice I can cancel. Cancelling is one way of simplifying. So we cancel the factors. Remember, it's factors that you cancel, not terms. So I cancel the a plus b with the a plus b factor there, right? And then I now have simplified it as a over a minus b, right? Just the question here. Can this a be cancelled with that a? No, because this is a term and you don't cancel terms. You always cancel factors there. So if you cannot apply strategy 1, the next option is you try to do factorization. Now let's look at our strategy number 3. Okay. Now if you cannot apply strategy 1, otherwise there's no simplification, you cannot factorize, then there's one more option left for you. And that one option is you can do apply trigonometric identities. And the identities I'm referring to you here are these basic ones and the ones that you get on your formula sheet, right? Remember the reduction one, that is part of strategy number 1 there. Okay. I just want to show you the 3 strategies, but just related to some everyday situation. Okay, let's say, for example, you don't feel so well today, right? Maybe you have a pain somewhere in your chest. So what's the first thing you do, right? You just maybe try some home remedy and maybe take something very simple and then see whether that will help you. Now, if you notice that that home remedy that I've tried is not helping you, what's the next thing you do? Then you go to a general practitioner and maybe he can examine you and he can maybe prescribe something. After going to him, you take his medication and then you notice it's still not working. Go back to him and then what does he say? He can refer you to a specialist. So if you're ill, you don't just immediately go to a specialist, right? I mean, try something first. Maybe it's something very simple. If that doesn't work, then you go one level higher and the next one there, right? Another example also. Let's say, for example, you have a car. You start the car and the car is not starting, right? You don't just pick up the phone and buy a new car. First of all, just check some basic things first. Is the battery in a good working order? Do you have fuel in? Did you actually use the right key for starting the car? If that is not right, now you've tried from your side, then you go to the next level. Maybe you can take your car to a workshop, okay, and they can maybe fix it, right? Now if you take it to the workshop and you notice you couldn't fix it, the workshop couldn't fix it, in other they tell you this car can't, then you got the next stage now would be buy a new car, right? But if something is wrong with your car, you just don't go straight to buying a new car. You first try this and the first simple things, and then that maybe you take to a workshop, and then maybe you can go that way. And there are many situations like this in everyday life. So without trig equation, you always try to simplify first. If that does not help you, go for the next level, which is factorization. And if that doesn't help you, you go to identities. Don't jump to identities, right? When you can simplify. Don't jump to identities if you can factorize there, right? And you always try to do it in this order. If you factorize, maybe you see after factorizing, you can simplify further, right? Or once you have an identity, you might notice you can simplify after that. And so always do it in this order here. First try simplification, then factorization, and then identities. And this is what we're going to do with the next few slides to illustrate these techniques to you with some specific examples. Now let's see how we can apply these three strategies to the simplification of trigonometric expressions in the next few slides. Let us consider the first example. Okay, there we have an expression that needs to be simplified. So we're going to start off always by using our first strategy, right? And what is our first strategy? Our first strategy there is to check, do I have like terms? No, right? Can I cancel out anything? No, right? But what do you notice can you do here? There are some identities, reduction identities that can be applied. So we just apply our reduction identities. Otherwise, you're going to simplify that. Sine 180 plus x, I'm going to write down a simpler expression. Tan x minus 180, I'm going to write down a simpler expression. Cosine, so you can write this in a simpler form. So sine of 180 plus x, we can get that as negative sine x. Tan of x minus 180 is positive tan. Here we have a co-ratio, and that becomes sine of x. Right, now we've done that. And now once we've done this, we ask ourselves again, are there any like terms? No. Can you cancel? Yes. You can still simplify. So I can apply strategy. You keep on doing simplification. So we can simplify by cancelling. And what do I cancel? The sine x with the sine x, and then I end up with negative tan x, right? Now let's consider example number 2. There we have an expression that needs to be simplified. So we always start with simplification, right? Now, are there any like terms? No. Right? The denominator is only 1, so I can't simplify that any further. No like terms. I can't cancel. I can't cancel this cosine with that cosine. And there's no reduction formula. But I see there are brackets. So I can simplify by expanding the brackets. And if we simplify that, that becomes sine x plus sine x cosine x minus sine x over cosine x. Now once we have that, we ask ourselves again, can I simplify now? Yes, I can simplify by looking at the like terms, and the like terms are the sine x and the negative sine x. And if I simplify them, sine x with negative sine x gives me 0, and now I end up with sine x cos x over cos x. Again, I ask myself, can I simplify? Right? Simplify that, and I notice I can cancel. So I cancel out the cosine, and there I've now simplified that, right? So quite often, strategy 1, go back to strategy 1, right? If you see another, because there could be other strategies, types of simplification that might work, right? So if you try strategy 1, doesn't mean you now have to go to strategy 2 next, right? Always go back to strategy 1. Any step, always go back to, can't I simplify now? Are there like terms? Can't I cancel out? Now let's look at another example so we can show you how you can illustrate strategy 1. Okay, first of all, we want to simplify. Any like terms? No. Right? Any brackets to remove? No. Right? Any reduction formula? No. But we have fractions here. And what can we do if we have fractions? Yes, you can find a common denominator. And what would that common denominator be? That's correct. Cosine times 1 minus cosine x. Okay. Now to get the numerator, so it's 2 times 1 minus cos x plus 1 times cosine of x. Right. So there we applied using a common denominator. Go back to strategy 1. Any like terms in the numerator? No. Okay. So what can we do here? When we'll remove the brackets, we expand. So we expand there. 2 minus cos x plus cosine x. Again, you ask yourself, can you simplify now? Yes, they are like terms, the 2 cos x and the cos x. So we can simplify that, and that gives you 2 minus cos x over cos x 1 minus cos x. Can we cancel here? No, we can't cancel this cosine. This cosine x is a factor, but that cosine x is a term. We can't cancel a factor and a term. And there we simplify that. So throughout in this one, we just use our strategy 1. Now in the next example, we're going to go on where we're going to use our other strategy. Look at our first example. Okay. First of all, we always see whether we can't apply strategy 1. Can we simplify? Are there any like terms here? No. Can we cancel? No, we can't cancel that sign with that sign. Are there any brackets to remove? No. There's no reduction formula. Okay. So we have now try strategy number 2. And what is strategy number 2? Can we factorize? That's the only technique for strategy 2. And yes, we can factorize by taking out the common factor. Sin x cos x plus 2. Okay. Again, go back to strategy 1. Can we simplify what we've done here? Can we simplify? Yes, we can simplify. So we can simplify by cancelling. So I cancel the sin x and the sin x, and that leaves us with cos x plus 2. Right? So always strategy 2, you go back to strategy 1. Don't go to strategy 3. Strategy, always see whether you can't simplify. Whenever you do something, can I simplify? Can I simplify? And remember, there are many techniques of simplifying there. Look at example number 5. Okay. If we look at this example, we always try strategy 1. Any like terms? No. Can we cancel anything? No. Reduction formula? No. Right? So then we're going to try our next strategy, which is factorization. If you look at the numerator, what type of factorization do I get in the numerator? That's correct. I can get a trinomial. Tan x plus 3 and tan x minus 3, 2 factors. The denominator, what type of factorization is that? Common factor. Sin x into 3 plus tan x. Again, you go to strategy 1. Can we simplify? Yes, what type of simplification? We can just cancel the factors. Right? So I cancel the 2 factors. And then I end up with tan x minus 1 over sin x. And there we simplify it. Now let's look at another example here. Okay, so first of all, let's see. Are there like terms in the numerator? No. Are there like terms in the denominator? No. Is there anything we can cancel? No. Are any brackets to remove? No. So strategy 1 cannot be applied. That means I need to try strategy 2. And what is strategy 2? Factorize. Can I factorize the numerator? Yes. What type of factorization? Common factor. There is the common factor. Okay. Now I have to now look at strategy 1 again. Are there any like terms here? Can I cancel out? Nothing. So I have to now try to factorize further. Okay. After 1 you go to 2. So I can factorize. Yes, I can factorize 1 minus cos squared x, which is 1 plus cos x and 1 minus cos x. Now, strategy 1 again. Like terms, can I cancel or what? Yes, we notice we can cancel. You can simplify by cancelling. What can I cancel? 1 plus cos x with 1 plus cos x. And there I have my solution there. Okay. So always when you finish a particular step, go back to strategy 1. Now let's consider another example. Okay, first of all, are there any like terms? Any like terms there? No. Can I cancel out anything? No. Right? Can I factorize? No. So I cannot do strategy 1, I cannot do strategy 2. So now I have to use strategy 3. What is strategy 3? I need to use an identity. Right? You see an identity? That's correct. There is an identity. And what is that identity? Tan x. And tan x is? So I replace tan x with sin x over cos x. Okay. Go back to strategy 1 again. Can we simplify this? Yes, we can simplify. What can we do by simplifying? We can cancel. So I cancel out the cos x with the cos x. Right? So now I write down what is left. And that gives me sin x plus sin x. And what can I do with that? What do you notice here? See again strategy 1. Like terms. And like terms can be simplified. And that gives me 2 sine of x. Okay? So I use strategy 3 and I go back to number 1 again. Always back to number 1. Okay? And see whether you can't simplify. Let's look at example number 8. Okay. Start first of all, strategy 1. Are there any like terms? No. Can I cancel? No. Can I remove any brackets? No. Reduction identities? No. But what do I have here? I have fractions, and fractions is strategy 1. For fractions can always be added by using a common denominator. There's a common denominator, 1 plus cos x with sin x. Now I get the numerator. So that's going to be sin x with sin x, and then 1 plus cos x with times 1 plus cos x. Okay. Now if I look at that again, always go back to strategy 1. No like terms, but there are brackets, so I can remove the brackets. Expand. There we've expanded that, sine squared x and 1 and 2 cos x and cos squared x. Right. Now let's look again there. Any like terms? No. Can I factorize? No. So I can't use strategy 1 again. Right? I can't use factorization. So now that brings me to identity. Do you see an identity there? That's correct. Sine squared plus cos squared. And what is that? 1 plus 1 plus 2 cos x. So sine squared x plus cos squared x, I use the identity, which is 1. Okay. Now let's simplify that. 1 and 1 is 2 plus 2 cos x. Now let's look at this again. Any like terms? No. Right? This is already factorized. No like terms there, but what can I do with that? That's correct. I can use strategy 2. I can factorize. And that is taking out a 2 as a common factor. Now, go back to 1 again. Can we simplify? Yes, we can simplify by cancelling. Cancelling out 1 plus cos x with 1 plus cos x. And there's my solution. 2 over sin x. Now let us look at another example here. Okay, first of all, we always try to see whether we can't simplify. Right? In this case here, we notice there are no like terms, there are no brackets to be removed, there's nothing to be cancelled, but I see that I have reduction formula that can be applied. So I'm going to use my first strategy, simplify by using reduction formulas there. Cos of 90 becomes sine of 2x. Tan of 180 plus is tan of x. Sine of 360 minus x, that's in the fourth quadrant, so it's negative sine of x squared. Okay. Again, I try strategy 1, and I notice there's no like terms, and there's no common. I can't even use strategy 2. There's no common factor, so I have to use an identity. Okay. There's no simplification that I can do there. There's no factors I can take out here. So I want to replace my sine of 2x, and I replace it with 2 sine x cos x, which you get on the formula sheet. Tan of x is an identity you need to know. That is sine x over cos x. Okay. Once I have that, I go back again. Can I simplify? Yes, I can simplify by cancelling out the cosines. So I cancel out cosine and cosine. I can then simplify it, and that gives me 2 sine squared x plus sine squared x. Sine x times sine x is sine squared. Again, I try to simplify, and that gives me 3 sine squared x. There we've simplified that expression there. Let's look at our last simplification example. Okay. First of all, no like terms. Cannot cancel, there's no brackets to remove. But I've got fractions, and fractions can be simplified. Otherwise, I can use strategy 1 by using a common denominator. What's the common denominator? Cos of 2x. And there's my numerator, 1 plus sine of 2x. Cos of 2x there. Now, there's no like terms. I can't cancel at all. And I can't factorize either. So I have to use strategy 3, an identity. Identity for what? That's correct. There's a sine of 2x. I can write down identity for sine of 2x, which is 2 sine x cos x. But for cos of 2x, there are 3 options, right? Now, you always look at what you have already. Here I've got sines and cosines. So it will be a good bet that we take the one with cosine and sine in. In other words, we use the one cosine squared x minus sine squared x. If there was only sine in the numerator, then I would have chosen the one with the sine only. If there was cosine, I would preferably choose the one with the cosine. Now, if we look at what we have here, there's no like terms, no cancelling, and I can't even factorize. So I have to use another identity. Now, which identity here? That's correct. There's an identity for 1. 1 is sine squared plus cos squared x. Right, here we replace 1 by a sine squared plus cos squared x. Now, no like terms, cannot simplify the numerator, cannot simplify the denominator, but I can factorize. That's correct. The numerator is a trinomial, and I factorize the trinomial. Sine times sine is sine squared, cos times cos is cos squared. Okay, and there I've got my factors there. The denominator I can factorize, it's the difference of 2 squares. And now, back to number 1, simplify. Here I notice simplification involves cancelling. And there I've got my answer there. Cos of x plus sine of x over cos of x minus sine of x there. Okay, and I can't go further with that. I can't cancel anything there. And there I've solved that. Let's do one more example. Here we have to simplify, and the restriction here is without using a calculator. In other words, we can't enter this in the calculator and just get an answer. That will not be acceptable. So let's see there. So what strategy are you going to apply here? There's no like terms. There's no cancelling that can take place, but we notice here that we can. That's what we can use a reduction. We can reduce this 312 degrees to an angle in the first quadrant. We can reduce this 198 degrees to an angle in the first quadrant. Okay? So let's see there. Sine of 312 becomes negative sine of 48. Cos of 198 becomes negative cos of 18. Sine of 45, 90 minus sine of 42. 90 minus 42 is 48. So that becomes cos of 48. Sine of negative 18 is negative sine of 18. Okay, we like to simplify that. So we can simplify. Negative times a negative times a negative is a positive, and a positive times a negative is a negative. Right, now if we look at this, we can't simplify further. There's no like terms here. We can't factorize. So we can do it right. Strategy number 3, we're going to use an identity. Do you recognize the identity? Sine cos minus cos sine. right? That's 48 and 18. We can use the compound angle identity, which is 48, and there's a subtraction, so I subtract the 18. Then we need to simplify that. 48 minus 18 we can easily simplify. That is sine of 30, and sine of 30, you don't need a calculator for that. That value is 1 over 2. And there we've simplified that expression. Now here we're going to apply our strategies, but to proving trigonometric identities, and we're going to look at a few examples here. Let us look at our first example here. Now, if you want to prove an identity, you have to show that the left-hand side is equal to the right-hand side, or the other way around, that the right-hand side is equal to the left-hand side. Now, usually we always start with a side that needs to be simplified. Now, if I look at the right-hand side, that looks like quite a simplified form already. So we're not going to start with the right-hand side, we're going to start with the left-hand side. But it doesn't always mean that you have to start with the left-hand side. Let us start with the left-hand side here. Now, if I look at the left-hand side, and I want to apply my strategy here, I can see that you always try to start with strategy 1. I need to simplify that. And what do we notice here immediately? There's some reduction formula that can be applied here, right? So we're going to start with strategy 1 by simplifying. So let us take the first factor here. Sine x, that remains sine x. Cos of negative x becomes positive cos of x. And I go to the second factor. Here I have a 90 involved, and this one here becomes the cosine, then changes to sine of x, but it's positive sine of x. 360 minus x, that remains a cosine, so that is cosine of x. That's in the fourth quadrant, or as I showed previously, you could use your calculator to verify whether it's positive or negative, right? Now I've done the first step. Now if I look at this here, there's no like terms in this factor, and there's no like terms, so I can't, and there's nothing for me to cancel either. But I have some brackets here, so I can remove the brackets, right? In other words, I can expand that, and if I expand that, I end up with sine squared plus 2 sine x cos x plus cosine squared of x. Now if we look at this here, there are no like terms, there's nothing to cancel. I'm not going to factorize this, because if I factorize this, I'll be back with what I started in the first step. But what do we notice then? We could apply strategy 3. Otherwise, there needs to be an identity. And what is the identity that you see there? That's correct. Sine squared plus cosine squared. That's an identity. And what is that equal to? Sine squared plus cosine squared is equal to 1. And then I end up with 1 plus 2 sine x cos x. But what do we know? But notice about 2 sine x cosine x. That's correct. That's also identity, which you'll find on the information sheet. And that is equal to sine of 2x. And now if we compare this, it's exactly the same as our right-hand side. So there we've proved that the left-hand side is equal to the right-hand side. So we've proved the identity. Let us consider a second identity here. So we want to prove this identity. Again, you can see which side are we going to start with? The left-hand side, because the right-hand side is already in a simplified form. So we're going to take the left-hand side. And now if we take the left-hand side there, we need to see, if I look at the numerator, there's no like terms. There's nothing that I can cancel. I cannot cancel this cosine with that cosine, because this is a factor, but this cosine is part of a term. I cannot cancel that. And so if I can't apply strategy 1, I have to go to strategy 2. And what is strategy 2? That's correct. I can take out a common factor. But is there a common factor there? No, there's no common factor. I cannot take out this sign and this sign. There's no common factor. So if there's no common factor, it leaves me with the third strategy. And what is the third strategy? That's correct. We have to apply an identity. So we're definitely going we can't simplify, we can't factorize, so now we have to apply an identity. And which identity we're going to use here? That's correct. You can see there the sign of 2x, and that you get directly from the formula sheet, and that's 2 sine x cosine x. Okay. Then after we've done that, we should now be used to, we go back to number 1. We can simplify that by removing the brackets here. So if I do that, I end up with 2 sine cubed x plus 2 sine x. Cosine x times cosine x is cosine squared, right? It's cos squared. So I've expanded that. Now again here, are there any like terms? No like terms. Anything to cancel? Nothing to cancel, right? So we can't simplify this any further. So now we try the second one, which is factorize. Is it possible to factorize? Yes, I can factorize. What type of factorization? That's correct. I can take out a common factor being 2 sine x. So I take out the common factor 2 sine x. I end up with sine squared x plus cos squared x. Now, back to number 1. Can we simplify? Can we cancel? No. Right? And I've already just factorized. Now the next one here is, let's see whether there's an identity here. Yes, there is an identity. And what is that identity? Sine squared x plus cos squared x, right? That is equal to 1. And we also see another identity here. Sine x over cos x is equal to, that's correct, tan x. So let's see that. Sine squared x plus cos squared x, that becomes a 1, right? And multiplying by 1, I don't have to write down times 1. And there I have 2, and sine x over cos x is my tan. And if I look at the tan x, 2 tan x, it's exactly the same as the right hand side. So here we've also proved the identity. Let's look at another identity here. Which side is obviously the one we're going to start with? That's correct, the left hand side. So we're going to start with the left hand side. Now if I look at the left hand side here, if I look at the numerator, any like terms? No. If I look at the denominator, any like terms? No. Right? So I cannot simplify the numerator, and I cannot simplify the denominator. And there's nothing also to cancel from the numerator and the denominator either. Right? So let's try the second strategy, which is factorization. Can I factorize? No. There's no common factors in the numerator, and there's nothing. So I'll have to use an identity here. So simplification didn't work, factorization doesn't work here. So if I look at that, and where do you see the identity? That's why it's quite obvious that is going to be the tangent that we're going to change there. So tangent there is sine x over cos x. But if you look at the denominator, there's a sine squared x. And I can change that sine squared x to 1 minus cos squared x. Okay? So now I've done it. And then always you go back to strategy 1. Can we simplify now? If I simplify the numerator, yes, I can simplify it by cancelling out the cosine. So I can cancel that cosine, and let's take out the 2, so I have another cosine left there. And if I look at the denominator, that's right, we can simplify. There are some like terms. -1 with +1. That can simplify. And now I write down the simplified expression. That's sine x minus sine x times cosine x. In the denominator, I've got cos x. And there I have a negative cos squared x. Again, there are no like terms. There's nothing to cancel. So I'll have to try to factorize. Possible to factorize? Yes, we can factorize. So we factorize the numerator by taking out sine x, and I get 1 minus cos x. Take the denominator, I factorize it, I take out cosine x, I end up with 1 minus cos x as well. Okay, now again we go back. Strategy 1, we can cancel, right? We can cancel out the 1 minus cos x and the 1 minus cos x. It's obvious. Now if I look at that, nothing further to cancel, nothing to factorize. Any identity? Yes, we see the identity obvious. Sine x over cos x is equal to tan x. So I apply my identity. Sine x over cos x, that's tan x. And now I see tan x there is equal to the right-hand side. So again, there we prove the left-hand side equal to the right-hand side. So we've proved the identity there. Let's look at another identity. Obviously, there we're going to start with the left-hand side. Okay, so we want to find the solution. Again, we start. Can we simplify the numerator? No like terms. Can we simplify the denominator? No like terms, right? So we see that, and there's nothing to cancel. You can't cancel that 2x with that 2x. Don't be silly there. Then, so if I can't simplify, I now go to the next step. Can I factorize? Numerator, no factorization technique can be applied there. Denominator, so we can't simplify and we can't factorize. That means I'm now with my strategy 3, which means I need to apply an identity. Do you see the identities that need to be applied here? That's correct. Sine of 2x, and that is equal to 2 sine x cos x. And the other identity is cos of 2x. Now, you recall with cos of 2x, there are 3 options to use there. You can use cos squared x minus sine squared x, or you can use 2 cos squared x minus 1, or 1 minus 2 sine squared x. Which one? Now, if you look at the denominator, we already have a cosine. So it would be better to change this to another cosine in terms of cosine there. So we're going to replace the cos of 2x with 2 cos squared x minus 1. Okay. Now, we want to simplify. If I look at the numerator, there's no like terms. If I look at the denominator, there are some like terms there, right? So I can simplify the denominator, and simplifying the denominator there, that means I get rid of the 1 and the minus 1. Now, if I've done that, if I now look at the numerator here, I notice there I can't simplify it any further, but I can factorize. If I look at the denominator, I can't simplify further, but I can factorize. So we're going to take out the common factor, and there I have sine x and 1 plus 2 cos x, and I take out cosine, get cosine 1 plus 2 cos x. Okay, we can then again try to simplify that by cancelling out, and I now end up with sine x over cos x. And if we look at sine x over cos x, that gives me, that's correct, sine x over cos x is the tan x, which is equal to the right hand side there. And there again, we've proved the left hand side equal to the right hand side, so we've proved that identity. Now let's try another identity. So we have to prove that, and obviously again here we're going to start with the left hand side. Now if I look at the left hand side here, I notice on the left hand side there's nothing to be simplified here, right? There's nothing to cancel either, and I cannot apply factorization. So I cannot apply strategy 1, nor can I apply strategy 2. So that only leaves me then with a third option, which is applying identity. Do you see the identity? That's right. We can expand that using the compound angle identity there for cos of a sum of 2 angles. And if we do that, that's the expansion there. Be careful. Cos 45, cos x. And if there's a addition, it becomes a subtraction. Sine 45, sine of x. The same with the other one. I use the cos expansion here, cos identity. And that is cos 45, cos of x. Subtraction becomes addition, sine 45 there. Okay. Now, once I've done that, and now let's look at each of these expansions. What do you notice here immediately? I can simplify this by, that's correct, there's a special angle. I can simplify because I see the special angles in there. So I can cos of 45, that you can easily get, and that is root 2 over 2. Sine of 45 is root 2 over 2. Cos of 45 is root 2 over 2. Sine of 45 root 2 over 2. So you see the root 2 over 2 appears quite often. So what can we do that? So what do we notice now? What simplification can we use? Right? There's no simplification to be used any further here. But so we go to the next step, and that is take out a common factor. And the common factor there stands out, root 2 over 2. So I take out a 2, root 2 over 2 from this here. So I end up with cos x minus sin x. I take out root 2 over 2 there. There I get root 2 over 2. That's cos x plus sin x. Now we need to simplify. And what type of simplification? Yes, I can multiply 2 with root 2 over 2, and I can simplify that. And I could also, in this case, I've got cos x minus sin x, and cos x I can remove brackets, so I can apply strategy 1. So 2 with root 2 over 2 times root 2 over 2, that gives me just a 1. Okay. Then if I multiply out cos x minus sin x with cos x plus sin x, I end up with cos squared x minus sin squared x. And what do you know about cos squared x minus sin squared x? That's right, that's strategy 3. That's an identity, and that identity is cos of 2x. And now we notice cos of 2x is my right-hand side. So there again, I've proved that the left-hand side is equal to the right-hand side. So we've proved this identity here. Let's consider another identity. Again, we're going to take the left-hand side. If we look at the numerator, there are no like terms, and there's nothing to cancel. So we cannot apply any of the strategy 1 techniques. Strategy 2, can we factorize the numerator? No, we cannot factorize the numerator. So we cannot apply strategy 1 or strategy 2, which means I have to use identities. And which identity? That's correct. The tangent, we can replace that by sin x over cos x, and sin 2x we can replace by 2 sin x cos x. Right? Now we want to simplify. And what can we do here? That's correct. We have fractions, so there's a common denominator. The common denominator is cos x, so we can multiply both the numerator with cos x and the denominator with cos x. Right? If I multiply the numerator and the denominator by the same value, I'm not changing the expression there. So let's do that. So that cos x can cancel with that cos x. That leaves me with 2 sin x, and cos x times cos x becomes cos squared x. And cos x times 2 sin squared x is 2 sin squared x cos x. So we have simplified. Now, can I simplify any further? Nothing that can cancel here. So I have to use factorization. Let's see. Factorization, I can take out a 2 sin x in the numerator. There we've taken out 2 sin x in the numerator. Ends with 1 minus cos squared x. Now, as usual, we'd like to simplify. So the 2's can cancel, and I can cancel that sin x with one of the sin x's here. Let's take the 2 away. And now, if I look at what is left, I've got 1 minus cos squared x over sin x cos x. And there's nothing I can cancel further. I can't cancel this cosine with that cosine. And factorization is not going to help me here. So 1 minus cos squared x. 1 minus cos squared x. That should remind you of, it's an identity. 1 minus cos squared x is sin squared x. And there I've got sin x and cos x. I can simplify by cancelling out the sin x with one of the sin x's in the numerator. And that leaves me with sin x over cos x, which is, that's correct, it's tangent x. And tangent x, you can see it's your right-hand side. So there we've proved the left-hand side equal to the right-hand side, which means we've proved this identity. Now let's look at one more identity. We want to prove that sine of 3x is equal to sine x into 3 minus 4 sine squared x. Right? Let's see what we're going to do now. We have this 3x, and we want to write, if we don't want a 3x, the new expression needs to be in terms of x. And how can we introduce the x there? We split up the 3x into x plus 2x. So 3x, there's an x, I get x plus 2x, because later this 2x, I can break it down again. So now we're going to, with this sign x plus 2x, I can use an identity, and we use the identity that's on your information sheet. So that's sine of x, cos of 2x, plus cos of x times sine of 2x, right? We notice there's a cos of 2x and a sine of 2x, so you can use identities again. Okay, and now for the cos of 2x, remember there's three options, but our objective is to get sine, so I rather change this one in terms of the sine version of it, which is 1 minus 2 sine squared x. And for the sine 2x, we don't have an option. That is just 2 sine x cos x. Now what do we do next? Yes, we can use strategy 1. We can expand there. Let's expand that. So I get sine x minus 2 sine cubed x plus 2 sine x, and cos x times cos x is cos squared x. Okay. Now, what can we do now? What do we notice? We can't simplify further, but we can. That's correct. We can factorize. There's a sine x we can take out as a common factor. So I take that as a common factor. I get this expression. Now look at this expression here, this trinomial that we have there. And look at what our objective is. Our objective is to get sine. So we can't simplify that. It can't factorize, but we can use an identity. And we're going to use the identity for cos squared. And the identity for cos squared is 1 minus sine squared x. Now it's just a matter of simplifying. So we expand there, so that is going to be 1 plus 2 sine squared. 2 times 1 is 2. 2 times negative sine squared is negative 2 sine squared. And one more step, simplify further. There's some like terms. 1 plus 2 is 3, and negative 2 sine squared with negative 2 sine squared is negative 4 sine squared. And if we check this, this is exactly the same as what we have up there. And there we've proved that the left-hand side is equal to the right-hand side, right? So what we've done here, we've taken the 3x, split it up into a x plus 2x, okay? And then we work from there. Similarly, there's also an identity where you have to have cos of 3x, and you can also get an expression for cos of 4x. That will be an exercise for you. Now, the next here is an exercise worksheet for you. But I suggest before you actually attempt the problems in this exercise, go through these slides again, maybe pause, you try it on your own and see whether you can either simplify the expression, or in the case of the identities, try to prove the identities on your own, right? And then let's look at the exercises that we have here. Here we have 3 examples. The first one is proving an identity. The next one there is simplification of an expression. And here we have the third one there is an identity with a simplification then. And let's look at the next one. Here we have a simplification, an identity, and then another simplification. Let's look at the last 3 examples. There's proving an identity, so simplification, proving an identity, and here we have and here's something similar in number 8, where we have cos of 3x, and you must write it in terms of cos of x. And then here we have another identity, prove that tan a plus b is tan a plus tan b over 1 minus tan a times tan b. I trust that you have enjoyed this video lesson and cleared up the approach to simplification of expressions and proving identities. There are other videos also on trigonometry that I've prepared, as well as videos on other topics of CAPS Mathematics, grade 12. If you go to my YouTube channel, Maths with Armien, I would really like you to subscribe to my channel, and hope that you enjoyed and benefited from this particular lesson. Once again, thank you very much.